Folks, how's it going? This is Mr. Murray coming to you with a little video for Course 1 Honors. This is our due now for 5/18/2020, and welcome to, believe it or not, the 9th week of school closure. All right, this is nuts. We've been out of school for basically an entire term, and it's definitely been a challenge, but I hope that you've been able to find these resources to be helpful, and I hope that as we press on into this final stretch of the year, we can start to think about making sure that we've really gotten everything we can out of it so that we can be prepared for whatever next year brings. Okay, and so one of those skills is really mastering exponential functions. So what I've done here is I've given you this. I've told you let g of x be equal to 6 times 1/2 x plus 2 squared. Now, just to be clear, what I'm doing, and unfortunately it's difficult to write in Smart Notebook if you use the typing, it's basically this. Okay, you're doing 1/2 to some power. Okay, so what I want you to do, pause the video, create a table, thinking about the exponent, create a table, a graph, and do the analysis. Then when you're ready, unpause, and you can see what I got. So I'm going to think about what number would I start with if I was going to graph this, and I think I would start with -2. And here's why. The reason is when you plug in -2, you're going to be getting -2 plus 2, because remember, since it's an exponential function, where you plug into is an exponent. So -2 plus 2 is 0, 1/2 to the 0 is 1, and 1 times 6 is 6. So this is an indication, 1, 2, 3, 4. This is an indication already of two things. One, it's an indication of a shift by 2 to the left. And why is that true? And I'm sorry, this should actually be not on the +2, but the -2. It should be over here. So why is this that indication? So normally, when we plug into 1/2 to the x, when we plug in 0, we expect to get 1, because anything to the power of 0 is 1, as I showed you when I plugged in the -2. So now, the number, instead of 0, that will give us that exact same value in the exponent has been moved to the left by 2. So now -2 in the new function, g of x, will give you the exact same exponent as 0 in the parent function, right? And -2 is 2 to the left of 0. So that's an indication of 2 to the left. The other thing this is an indication of is a dilation by a scale factor of 6. And I know that because ordinarily we would expect to get an answer of 1, right? When we have 0 coming out of this, right? Because 1/2 to the 0 is 1, but instead we get 6, something 6 times as large. And we can also see that here, whatever we get for our normal exponent, our normal value, is going to be multiplied by 6, making it 6 times as large, moving it away from 0, either in the positive or the negative direction. It depends basically on a few factors, as we've discussed. So I've got -2, 6. Next, I'm going to try plugging in -1, because I would rather work with positive exponents than negative exponents if I have a choice. So -1 plus 2, that's going to be 1. Anything to the power of 1 is itself. So 1/2 to the 1 is 1/2. And then 6 times 1/2 is 3. So I'm going to put on -1, 3. It's important to find the y-intercept in any situation, so I might as well plug in 0. And the reason you're often going to be asked to find the y-intercept is because it's easier to find a y than an x-intercept, right? It's easier to just plug in 0 and see what comes out than to see what x would make y equal to 0. Those are very two different problems in many ways. So 0 plus 2, that's going to give me an answer of 2. 1/2 squared is going to be 1/4. And 6 divided by 1/4 is going to be 1.5. Okay, and if you think about a time, your hour on your time on your clock, right? If you take 60 minutes and divide it into quarters, right? 3, 6, 9, 12. Each of those quarters is 15 minutes long. Now, if I was to plug in 1, what I would end up with is 3. So I'd get 6/8. In other words, 3/4. If I plugged in 2, I would get 6/16, and that would be 3/8. So you can see what's happening here, right? 4s, 8s, 3s, if you can look at the pattern. So the other cool thing though about this is if you can think about it as like a geometric sequence, but then where you can just connect the actual points, unlike in a geometric sequence, then you can just use the b value like it's an r value. And if you look at the b value, right, the b value is 1/2. And as x goes up by 1, y is getting multiplied by 1/2. What that lets you do is that lets you, once you establish 1 point, all you need is 1 point, you're done. Because what the b value says is, okay, start at -2, 6. And I choose -2 to get that nice easy 6. Cancel out exponent out. Once you get that 1 point, you know that if I move x up by 1, multiply by b. If I move x up by 1, multiply by b. If I move x down by 1 to -3, I would be dividing by b. So what I would expect to see is 12. And let's see if that's what I get. When I plug in -3, I get -3 plus 2, which is -1. And then remember, 1/2 to the -1, you flip it, and you make the exponent positive. So it's 2 to the 1, which is 2. And then you have to remember, multiply that by 6. So you do indeed get 12. Okay. So here's my function right here. And you can see that as I go the other way, I'm getting closer to 0. You can also see the absence of a number, a k value over here, also indicates that I am most likely going to have asymptote of 0. Analysis, folks. So domain, -infinity to infinity, as usual. Range. Okay, so the lowest y can be is 0. That arrow, I'm going to do actually I'll do the analysis graph markers in black. This arrow pointing up indicates we're going to infinity. Where is it increasing? Nowhere. It's always going down. Think about the summer. Think about like a water slide. It's decreasing. Woo! We're always going downhill. Horizontal asymptote. It is y equals 0. If you said the x-axis, because that's the same thing, I would accept that as an answer. All right, and behavior. As x goes to infinity, f of x goes to, so as x is going to, actually let's do -infinity. As x gets really negative, what you can see is the y values are going up, right? -2 was 6, -3 was 12, -4 is going to be 24, -5 is going to be -48. So what's happening is, not -48, +48. But you get my point. As x is going up, or rather more negative, y is going up very, very rapidly. Okay, so what that means is that what's going to happen is as x gets really, 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 really negative, y gets really, 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 really positive. So you're going to write infinity. And then remember, on the other hand, as x goes to positive infinity, f of x is getting really close to 0. Not equal to 0, but so close that, remember, eventually your calculator is going to say, you know what, it's 0, because it's so close to 0. Okay, you can try to plug this in, but again, what's going to happen? Think about it. You're always going to have, no matter what, look at like 0, 1, 2, 3, or specifically 1, 2, 3. No matter what you do, you're always going to have a 3 in that numerator, And as long as your numerator is 3, your fraction cannot be 0, because it will never have a numerator of 0, right? So eventually it'll be like 3 over 3 to the power of a million, right? Like if x is 999,998, it'll be a half to the power of a million times 6. It's fine. That's going to be 3 over a really, really big number. It doesn't matter. The numerator is not 0. It's not equal to 0. It's very close to 0, but it's not equal to 0. And this is this idea of limits that you guys are going to see as you, one, continue to investigate more stuff next year and in the year before, and really as you go into calculus. And there's a lot of really, really awesome math around that. So if you're able to get this right, congratulations. Otherwise, I really encourage you to go back through and take a look at some of the stuff I've done here. But best of luck. Continue working hard on the stuff we've been doing. Don't forget to love math. And as I always say, you can do it. All right, until next time, guys, have a wonderful day.